Okay, so what I'm going to do is I'm going to run through for the last part. We've got a working game, but I'm going to run through a few things. I'm going to, first of all, I'm going to optimize it to see if I can get a bit more performance out of it. And then what I'm going to do is look at adding the multi-key press stuff. And then finally, just doing a bit of dehackification, I guess, because you notice with the dead proc that I looked at in the previous one where I had the game over looping around and going, oh, that's stuck in a loop. I went and forced a go to 23 into that proc, which is probably a bad practice, but it worked for what I needed to, and I got the game working. So now I can go through and I can kind of clean that sort of stuff up. Okay, so speeding this thing up. Now there's a couple of ways you can do that in Spectrum Next. One is you can add a line at the beginning, run, at, and then you can put like a CPU speed switch in there. So by default, 0 is the normal Spectrum speed at 3.5 megahertz, but you can increase it up to 3, and each time it doubles the previous value. So if I say 1, it then sets it up to run at 7 megahertz. 2 will be 14 megahertz, and 3 will be 28 megahertz. So essentially making the machine run horrendously quick. So if I run it at 3, see, it's pretty quick. It's making it a little hard to control, but it is a lot smoother, a lot quicker. I'll put it at 0. So one thing you should do in terms of this is I would recommend that first of all, before you even try crank out the CPU, see if you can get your program to run as fast as possible without relying on that as kind of like an easy fix. Okay, so you should always try and optimize the code down to be as fast, smooth as possible. And then if it's still a little slow, then crank up your CPU and get a bit more kind of grunt in there. Okay, so how am I going to optimize this thing down? Well, BASIC is not a fast language. It's interpreted, which means it reads a line, takes all the commands and all the things out of the line, and then executes all these little commands in the operating system. Now, one thing that takes time is variables, and also these values, or any number, and mathematics and everything else in here, because to be able to kind of work with a whole range of different numbers, from these whole numbers, the integers, into like floats, which are things with decimal points, it has to store all this information internally in a certain format, and it does it by kind of converting it to like 5 bytes of memory in a particular format. And I've got technical stuff somewhere about the mantissa and all these other things, but that conversion of a number into these 5 bytes of memory and then back again takes time. Okay, so that slows things down. And variables stored in basically like a table, and it needs to kind of find those in memory, work out where the number's stored, convert that number from 5 bytes back to that number that we're using, and then that takes time as well. So what you can do is you can actually speed things up by replacing out this system using integer expressions. So integer expressions basically is a system that kind of avoids the whole translation between 5 bytes and numbers and everything else, and directly accesses those numbers, stores them as whole values or integers, and also stores them in specific location in the memory of the spectrum, so that it can always find them very quickly. And these things just improve the speed immensely. So how do you do that? Well, you probably see this a lot, the percent sign. So the percent sign basically tells the Spectrum Next or NextBasic the following expression is to be, I guess, processed by this integer system that runs in the background, or this integer-based mathematical expression system doesn't run in the background. Okay, so use a percent, and that switches it into integer mode. Now you can have variables with a percent, and it'll store it in like a specific location, and it uses single letters, and it gives you 26. So you've got A to Z basically. So we can go through and we can do that. We can go percent. Okay, we can convert all of these. So all the in-game variables that are necessary for the speed, that are constantly accessed and used all the time, should be integer variables, just to get a little bit more performance in there. Okay. Now you don't have to have everything as integer variables. for instance, if you're got like high scores and stuff, and things that are outside the game loop itself, you can get away with just general variable names. Okay, but these things are faster, which makes them ideal. Oops, that's S is already used. See that? S for sprite, S for saved. No, we'll get R for rescued, and then %F. So yeah, so it's not used in the game loop, and you're not worried about it's not going to impact the performance. You can just use your normal variables. Sometimes it's nice to use them because more expressive than a letter, in terms of knowing what the heck does that thing mean. Because for this sort of stuff, you got to remember what all these letters are actually doing. Okay, you have 26 as well, so if you've got a lot of variables going on, it can be a bit of a mind thing. Okay, so I need to change these things. So B is the border. Okay, and like I said, the % sign indicates an integer expression. Now percent and letter is saying store, this is a variable. Okay, but you need to get the % at the beginning of any mathematical expression that's going to contain any of these types of variables. So for instance, we have B. Now you probably think we get 100 and then plus %B, but it's not going to work because you need to have the % at the beginning, because it has to be the entire mathematical expression has to be processed with this integer system. Okay, so % 100 plus B. This %, don't know, 0 plus B, but that's all right. Okay, and that works. Now there are some caveats, and there are some pros and cons to using integer variables. But what we'll do is I'll just run through putting these things in. Okay. Okay, here's our sprite, so it's %S. Okay, now, like I said, any expression that's going to have a integer variable in has to be integer-based expression. Now, not everything is an integer, I guess, function, and also integers tend to be unsigned, which means they're numbers between 0 and 65535. So we'll have a look at how we can kind of work with negative numbers, and also how to work with things like in key equals O, which basically is not integer based. But we need to do it in here. So if statement, the expression for that needs to be integer, because I'm going to be accessing the H variable. So we need to say, okay, here's the expression. Start here and go there and push enter. It's going to complain in key. That's not really an integer expression. So what you can do is say, well, actually, if we've got a variable name that isn't an integer variable, or we have something like in key $equals, we can actually tell the integer system to translate that by using int, int, and then you use curly brace and another curly brace around it, like that, and then it works. Okay, so anything that's not integer, like integer variable names or anything else, you can translate them by just basically going int and then putting curly braces around each side of them. Okay, and H is greater than -8. Well, that's fine. H is going to be the %H. Now, the problem is I said they were unsigned, so technically they have no negative value. So by default, anything that's going from -1, -2 is kind of like starting at 65535 and kind of goes backwards from there. Now we can actually tell the integer system that I do want you to actually convert whatever that value is, so it has a plus and a minus value, so I can actually see if it is negative. So you do that by going SGN, signum or sign, I think it stands for signum, curly brace again, and then the variable and curly brace, and that'll translate whatever the value is back into a signed one, 0, plus and minus. Okay, and then we're going to go in here. So that's the expression there. Then let, okay, so we're outside the expression, so we have to go %H again. And then after that equals, and then there's another mathematical expression. So %H again to start off saying this is all going to be integer based. Now you got a 0.5. That's not an integer. So again, we just go int curly bracket or curly brace, curly brace. Okay, so a little bit of a rethink in some of the stuff when you're starting to work with integers, but the benefit, the speed benefits makes them all worthwhile. Okay, we get the same in here. We can do the same in here as well. Okay, now the other thing to be aware of, and we'll do it with this one here, the space bar. So we go percent and be int because we need to convert that. We say I want you to go and run this inky equals check and then return a value. Okay, and fuel is greater than 0, and v, which will be sgn square brace, and in fact we'll probably put it on the f as well, because you never know, it might go -1. If we don't have sgn on there, it's going to say, oh, that's 65535, which is greater than 0. So we're going to go sgn on that one too. Then let, and we go percent v equals, and it'd be minus int curly bracket, curly brace, sorry. Okay, let percent s equals 1, and let percent f equals percent f minus 1, and then we just quickly do an update print in here. Percent f. Okay. Okay, now I'm going to go through the entire program and do this on every single thing, because it's going to get really kind of boring to watch me go to every line and go percent, percent, percent. So I've kind of done that, and I've saved it, but I thought I'd go through and I'll show you some of these key points in here so that you kind of know how these things work. Now, one of the other cons or caveats when you're using integer expressions is that it's sequential. Now, in normal mathematics, usually your multiplications get calculated separately to your additions. So you can get I times 16 plus 12, for instance. So we'll get I times 16 and then add 12 to it. Now, integer variables, and I wonder if I can actually go further down here. Let's see if I can find one that's going to give me, I think it's probably, let's have a look. Okay, so we go in here. Now I is not used by anything, so I'm going to percent I, which will make it a little faster. And I'm going to read percent A, percent B. If, no B's being used. Okay, so I'm going to I, comma, percent J. No, J, comma, percent K. I, J, K. Okay, these two aren't being used for anything. So plus I. That'll be like B. B. Okay, I times 16, that won't be B, that'll be K. And that will be J. Okay, I need some percents in front of that. Okay. Okay, so the reason I'm doing this one, I'm going to show you what you've got to be aware of. Okay, this one is not too bad because it's going to work. So what it's going to do is going to go I times 16 plus B. So it's going to just go that times that plus that. Now, if I was to do something in this order, you would think it'd be I and then B times 16. Well, it doesn't work that way. It's going to go I plus B and then times 16. So it's going to end up with adding these two first and then doing it. So unlike your normal maths, it's basically in order like that. So let's switch this one around and do it that way. So how do you get around that? Well, this is where you say, okay, well, I've got to actually group these things so they're calculated as separate blocks. So that's where you need to add brackets, and you'll see that quite a lot in integer expressions, that you do need brackets around things. Okay, so just to be aware of that too. Right, so those are, I think, are the main key things. Now, one other thing that's worth noting with variables, not variables, with integers, is that everything that has a digit in here, like restore 700 or 0 or 15, is stored in memory as that 5-byte representation, or basically it's extrapolated out to that format that BASIC uses to store numbers. And that's stored actually in memory, and so is the characters for 700. So it'd be like 700 and then 5 or 6 bytes of just gobbledygook in there. So if you actually go percent at the beginning of a number, what it does is it just stores it like that. It doesn't have all that extra stuff on the end, so you actually end up saving some memory. And also it can make things a little bit faster as well. So sometimes when you see some programs that people have written, you might see percents in front of all these numbers, and that's why. It basically optimizes the memory use a little. Okay, so that's worth kind of noting. Okay, so that's another good use for integer variables. Okay, so I'm not going to go through and do this while you watch me kind of put percent signs and rename things, because it'll be really boring. But hopefully that's kind of pointed out what they are and how they're beneficial. Like I said, manual, good, page 66. If you've got the manual and you're going, how did you find out that? Show you how I've organized mine, because there is no table of contents in the first release of this. I've actually just used post-it flags, and I've kind of flagged everything in the book that is important, so I can quickly find it by just finding the tag and flipping over to it. So it's a handy tip. There you go. Okay, so I'm gonna go and reload my optimized one, and I'll come back in the next video, and what we'll do is we'll continue and we'll look at dehackifying that dead function so that it actually calls it, exits it, and then does something with it. So join me in the next video.